Hi there. Hello and welcome to Cloud AI and Data Science Day 2020 from the Port Harcourt School of AI. We are super excited to be bringing this program to you today to help you understand the essentials of cloud and, of course, the importance of cloud for AI and data science workloads. So quickly, it's just we're just going through an introduction for you to really know what the session is all about, what the day is all about, who we are at the Port Harcourt School of AI, as well as what you should expect from the program today. All right, so of course you're here to learn about cloud AI and data science from two renowned experts in the space. First of all, of course, we have Lynn Langit, who will be bringing to us the essentials of cloud computing for machine learning and data science, an introductory session on that. Lynn, of course, talking about Lynn, she's the CEO of Lynn Langit Consulting, as well as a Google developer expert in Google Cloud Platform, an AWS Community Hero, as well as an MVP for the Microsoft Data Platform. So yeah, you're going to be learning a lot from Lean on the essentials for cloud computing, for essential cloud computing for machine learning and data science. Then up next, just right immediately after Lean's session, so you should perhaps stay on the channel. I mean, it should premiere just about 5 minutes after Lean's session or so, 5-10 minutes after Lean's session. We're going to be having Yufeng Wo, who is a developer and advocate for Google Cloud Platform, as well as the creator of the popular AI Adventure series on YouTube, which has garnered over 1 million views so far up to date. And he's going to be talking to us about machine learning on Google Cloud, just pretty much the workflow for ML on Google Cloud and how you can really optimize costs and make sure that you understand the cost performance trade-off landscape for when you're using Google Cloud. So this will be essential for small businesses or individual data scientists who really want to use cloud for their ML workloads, but on a budget, on a tight constraint budget. So stay tuned for this one just right after Lynn's session. So briefly, because we are trying to make sure that these topics are accessible and are useful to you right after, even after if you left the session so far. So we try to give you advice, the best practices we know for you to help recall and make these these sessions concrete in your head and so on. So I mean, if you're new to the space of ML, if you're probably watching this, although this is an intermediate level, these are intermediate level sessions. But if you're new to the space of ML, one thing of course we advise you to do is to take note of the terms you don't understand. Sometimes you might get blurry, sometimes the sessions might not really make sense, but take note of those terms you don't understand. It's good enough that you understand the things that you don't understand, and just take note of them, research on those terms, and engage with the community on social media. Ask questions from these experts or other experts and other members of the community, ML community online. It's a really, really friendly community. Ask friends, ask non-friends, ask people about the terms you don't understand, and let them explain it to you in accessible terms. You can also follow us on Twitter. We can also be able to help you connect to people or drive home those terms for you as well. So of course, take home best practices and good methodologies as much as you can. So this applies to both practitioners and as well as people who are getting started in the ML space. So best practices, I think these are things you should hold on to. You can learn everything pretty much about the session, but taking on best practices, rule of thumbs, tips, frameworks will be useful for you as you go along in your career. All right, so before we go on, let's just get to know us briefly. So who we are the Port Harcourt School of AI. So we're a non-profit just looking to make AI education and technology accessible for underrepresented group pretty much. Of course, we started from the Port Harcourt School of we started from the Port Harcourt city in Nigeria, but of course we're trying to expand now to make sure that our vision can accommodate a whole lot of people beyond our home city. Yeah, so of course while we do this, we have our reports. We pretty much do this because we're really passionate about making AI and data science technology, AI and data technology in general accessible, as well as the education itself, because education is really what matters to us, making Africans or pretty much our audience, our community data literate, making sure that they can really understand how to make decisions with data, as well as how to use these technologies to make their society a better place. So you can also follow us on Twitter to see more of what we do. We tweet a lot about a lot of things we do. So, but generally you can look at some of our programs. So we have free workshops and sessions from world-class experts in AI and data science. So we have those on our YouTube channel. So you check there on our YouTube channel, you should see where we've been hosting sessions from March down here now to August, so you can really check those workshops and sessions and learn from them. And we hope to do more. Leave your feedback in the comment sessions. We hope to do more going forward. So we also have a podcast show as well, tagged The African Data Scientist, a podcast where we get to tell the story of the African AI and data science potential. So you can check that out. The links are in the description for both our YouTube. Of course, you're probably on our YouTube channel now, or for our podcast show, you can check the links in the description for listening to our. We are on our perhaps our 7th episode. Yeah, we are on our 7th episode, so you can listen to those very, very, very useful. Bringing in useful experts advice from these people, and they're helping your career a lot. And we also engage in community building, and there are lots of other programs we have in store. Just trying to say, which of course are all centered around making AI and data science technology accessible, as well as the education as well. All right, so our story so far, we've taught kids in Port Harcourt City, we've taught adults, we've had meetups, we've had sessions, and you can pretty much read our report from last year. We're hoping to release one for this year soon. You can also follow us on Twitter, and also visit our website to to learn more. So how can you support us? So currently we have a link to our donor box and our GitHub sponsors link, I guess, in the description, so you can check that out. But otherwise, if you want to get in touch with us, we are still on the Port Harcourt School of AI. Sorry, just okay, just give me a sec. So we are on Port Harcourt School of AI at gmail.com. Just give me at gmail.com. Yeah, so you can check us out. You can send us an email. We respond as fast as we can. But otherwise, yeah, you can find ways to support us. Buy books. That we are affiliates with Amazon. Please purchase the books. We have top best-selling books from our experts who have come to the platform. Please help purchase these books, and so that we can get a commission from Amazon to keep doing what we do. Most of these things are all volunteer sponsored, so it will be helpful if you can help donate cash, donate your time, resources, wherever you can really help the community grow, and help us keep doing more, keep improving, and keep chasing our goal, our mission, our target. Yeah. So where should you go from here? Of course, we expect that you join an AI learning community in your region, because we advocate for community-driven learning a lot. So if you've not joined any community, AI learning community yet, join. Find some in your area if you have one. If you don't have one, you don't have an AI learning community, please create one. Start one. Start engage people, build a network, and help people. Really help people gain access to the AI space through this community-driven learning method. So it's absolutely crucial. Thank you. If you do just that. So explore more on the topic for today's session. So cloud ML, explore more cloud AI, and all of these things are absolutely crucial. And get started. If you haven't started learning ML yet, if you haven't started doing ML yet, now is the best time perhaps for you to get started. Start. I mean, yeah, there are a lot of difficulties around there, but with a community and with people willing to help mentor and guide you, it's easier for you to the barrier of entry is pretty much lower than it usually is. So ask questions on Twitter, get in touch with experts. It's a friendly community, like I said, and the general AI community members there. So you can also join us. We have lots of programs that will engage our members coming up soon. So we are still trying to make sure that we are planning for these program sustainabilities. So you can join us on our Slack. And you can also join us on, you can follow us on Twitter, which will be very useful as well. All right, so I think we're done, and see you in the session, because I think we've explained a lot about this session with experts. So see you in the session. Bye.
Hello and welcome. I'm Lynn Langit, and this talk is Cloud Practices for Machine Learning. I've made the slides publicly available, and I'll give you the link at the end of this talk. So the topic is expensive, and I really want to, during our time together, lay out both a plan and information so that you can go through this plan and have success with Cloud for ML or machine learning. And the way I see it is there are certain percentages, almost like the battery life on your phone. And a common situation I see when people are getting started with cloud ML is they want to skip steps. And that leads, in my experience, to ineffective results. So we're going to take this very systematically. And we're going to start with data and questions, then look at development environment and cloud environment. Then we're going to look at what I call Hello ML, so Hello World for machine learning on cloud. Then data samples and security, model quality, and scaling and reproducing. So in addition to resources, I'm going to talk about some of my experience as a production cloud ML architect. In particular, I've been working in bioinformatics, so genomic sequencing. So speaking of that, it's important to start with the business problem that you're trying to solve. ML and cloud are both moving really, really quickly, and there's a lot of really exciting technology that we as technologists can allow to lead our thinking. For example, something that I've been exploring purely from a learning standpoint rather than from a business standpoint is a machine learning algorithm that's very advanced. It's designed for implementing, as it says here, hybrid quantum classical neural nets. It really doesn't get more advanced than that. So you have quantum computing and neural nets, and this is the open source TensorFlow. Now this is shown running in a learning environment. This is actually Cloud ML. This is running on Google Colab, which is a Jupyter-style notebook that's running on Google Cloud infrastructure. And what I find is a lot of people that are trying to work with Cloud ML, myself included sometimes, get distracted by some of these new technologies. And when they go to build, they don't focus on the business problem. And it's extremely important to deliver value with Cloud ML solutions, like any software solutions, that you first focus on solving the business problem and you select all the other parts and pieces later. So for this particular case, although you might be thinking about, and this is just a little snippet of the code, working with TF or TensorFlow and the Keras library and working with quantum and everything else, it's really not the best place to start. The best place to start is, what is the business problem that you're trying to solve? So one of the problems that's very timely that my company has been involved with is helping biologists do research in finding solutions for COVID treatment and for vaccine research. And again, very compelling problem. Problem comes first, and machine learning comes second. That's really the important thing to think about here. So when you are thinking about your problem domain, you want to start not with your machine learning algorithm, not with your TensorFlow, or whether you're using regression or something out of scikit-learn or writing your own algorithm. You need to start with the data. And starting classic machine learning, you're going to have all different types of data. Probably you're going to start on your laptop, maybe from some experimental research. And you need to think about how frequently that data is going to be updated. Now, in this fast-moving world of Cloud ML, in my consultancy for COVID, we're getting data in on a basically almost daily basis. The thing that drives this or moves us to cloud is the amount of data. So one of my clients, which is the Broad Institute at MIT and Harvard, has publicly stated that they are putting in, and this was pre-COVID, this is for their cancer genomic research, to the Google Cloud, 17 terabytes per day. So this is moving our data to the cloud because it no longer fits not only on a laptop, it also doesn't fit on our university research cluster or any other on-prem resources. But I am getting a little ahead of myself. Before I talk about cloud scale, you have to go to the basics. You have to think about, what is your data and what is the quality of your data and what data should be included, because this is extremely important in any data modeling, but more so in machine learning and even more so in cloud machine learning. So just a thought exercise. Picture a triangle. Think about something simple that we probably all would have a similar representation, right? Well, wrong. I was just drawing the other day, and if you think about it, something as commonly understood as a triangle, has many, many different forms in data. And this is extremely important when you're working with any machine learning model, to consider the applicability, the quality of the data. Now, you want to start with sample data. And in some domains, this is easy. Sometimes you can just get a text file, find a text file. But in other domains, like the one I'm working in, genomics, it can be really difficult. I actually made a repo up on GitHub, and I have all these linked. And inside of here, I have sample data, and any of you could use this. So this could be useful when you're just trying out an algorithm for CSV data. So that, kind of simple data. These are small data sets. But if you're working domain specifically, so I'm working with genomic data, you can see that you have all these types of data. And you probably, unless you work in genomics, have never heard of these file types other than CSV or TSV. But the important aspect is when you are doing any sort of machine learning, cloud even more so, you want to have appropriate sample data, whether you create it, find it, save it, or whether you get it from one of the cloud vendors. Now, and this is the link to that. Now, a trend in cloud data in general, but particularly applicable to machine learning, is the cloud vendors are putting some sample data sets and some production size data sets up on their clouds. Now, this is an important trend for cloud ML. You're going to hear me say over and over in this talk, you want to move away from doing work on your laptop, which this is a paradigm shift. This is really very new. Most of the machine learning professionals I work with still do the basic modeling on their laptop. And I'm going to really challenge you to move away from that. And you might say, well, what do you mean? Well, you first want to start with the data that you're going to do your computer, your machine learning on. And if that data is already in a vendor cloud, then you're going to start by working in that cloud. Now, what do I mean by this? There are, across all the major cloud vendors, both data sets and in many cases data set search. I personally think that Google's is the most useful, and so I tend to use that. So what does that look like? So this is out of Google research, and I'm just going to click the pre-populated search here, coronavirus or COVID-19. And you can see that we have over 100 data sets found, and we have all kinds of filters that we can look at. We have usage rights. We can filter it to free data sets if we want to, and then we can explore those data sets. The quality of the data is extremely important in the effectiveness of a machine learning model. And you can iterate over that faster in the cloud if the data is already in the cloud. A pattern for cloud ML is to avoid uploading and downloading data up into the cloud and down from the cloud onto your laptop. Again, you just want to get away from working on your laptop in general. Now, in addition to this, the vendors have data sets that are permissioned, in my case, for public health. So health researchers who have been trained in compliance law in the United States, that's HIPAA, can have access, for example, to genomic data sets. And this is a really important pattern when you're working with cloud ML. So talking about your dev environment, I've been introducing the idea, but the point is you're going to be implementing your cloud machine learning model on the cloud. So it's a very important pattern to build your dev machine on the cloud. Of course, that necessitates you have a very fast internet connection, which I realize is not always possible. So there could be an exception to that. But if you have a fast internet connection, you really want to use the cloud as your laptop. And I consider this a huge time saver. I have answered hundreds of questions from people trying to set up a dev environment, installing R libraries, installing GPU drivers, installing all kinds of stuff, and having a lot of difficulty, taking hours or even days to set up a dev environment. And then if it's a team, when the next dev comes in, taking that same time over again. I really encourage you to take a look at what's available up on the vendor clouds. So when you're setting up your dev environment, you can set up your virtual machine from an image. You can use a Jupyter notebook, or you can use a machine learning Docker container image. Again, all three vendors, Azure, Amazon, and Google, have these solutions. In Google, which I'm showing here, they have something called the AI Hub in the Google Cloud Platform. And you'll notice the very first link here is a TensorFlow deep learning virtual machine image. So if you wanted to test out that first scenario, if that was a fit for your business problem that I showed you in this talk, the TensorFlow Quantum, rather than trying to somehow set up simulators on your laptop, you literally would go to the Google Cloud and click that first link, and you would be set up and ready to go on a virtual machine. This is a huge time-saving tip. And then when you get the next dev on your team, that person does the same thing. So you really want to look at what the vendors have set up for your dev environments. And I've done a number of courses on lynda.com, LinkedIn Learning, where I've explored the different services for machine learning. And in those courses, I personally use all these images because they're faster. So speaking of cloud, one of the challenges for this talk is I'm really far away from you. I'm about as far as you could be. Actually, today I'm in Fargo, North Dakota, visiting my family. And although I've been to the African continent, I've never been to Nigeria. Hopefully, some point in the future, when all this craziness, we get past it, I can come and visit you. I would love to come. I have been to some countries in Africa, but never Nigeria. So given that, I really don't know which clouds work best in your country. Of course, the data centers, as far as I understand, are not in Nigeria at this point. So that's something you're going to have to research. When I visit different places in the world, one of the first things I do is I go and I try to connect and make a virtual machine on each vendor's cloud to see which one works best for me in which data center. So that's a quick way to test it. Irregardless of that, when you pick a cloud, what I have done, again, is because I have so many resources, and some of these are courses, 30 courses on LinkedIn Learning, but I have more than 10 GitHub repos. I have 40 technical articles on Medium. I have 50 YouTube videos that are free. I have microblogging. I have just so many resources because I've been working in cloud for more than 10 years. So what I have done is I basically created a repo, which is an index to all my other content. And so when you get started, you might want to start here if you're not working on cloud already. So the repo is just called Learning Cloud. And basically, each folder has information. So if I go to the GCP folder, the first thing that I show you is where are the data centers. And then I talk about my courses. And then I have my repos, my articles, my YouTube, and then other resources, in this case from Google, that I think are useful. So this is a good starting point when you're trying to figure out if you're new to cloud. Like you can just go kind of quickly and you can say, okay, which of these clouds do I want to try out? Because I do production work in all 4 of them. I would recommend that if you don't know which one to start with, do that speed test and see which cloud vendor in which data center comes up fastest, because cloud's all about speed. Oftentimes it's Google because Google has their own infrastructure, but not always. So you're going to have to test for that. So once you pick a cloud, before you start working with machine learning, you need to do the basics. And a lot of people new to cloud skip this and they run into problems. So you need to set up an appropriate account. You can do free tier when you're just starting, but when you're putting anything into production, you have to set up a company account. Do not put anything into production on a free tier. And you have to set up billing. And I would recommend you set up a billing alert for your training or dev account, that if you spend over, it's usually 50 or 100 bucks, you get an email, because you really don't want to get a shock bill from forgetting to turn something off you've been trying out. And also, you have to understand something about security. This is so important in any solution to deal with data. We keep having these embarrassing mistakes in our industry because we as developers don't set up proper security. So again, with these various clouds, I've set up these repos, I have these courses. So the one that probably gets the most interest, because I call it the missing GCP course, is Google Cloud training materials have a lot of assumptions built into them, assumptions of knowledge. And so when I was learning Google Cloud many years ago, I had to struggle. And so I created a course, which I call the missing course for GCP, that you can see starts out with setup and IAM, which is security, then goes into storage. So this course has text links, it has screencasts. The idea is to get you set up properly. So you need to do the basics, whether it's GCP or Azure or whichever one. Okay, so you've kind of found some data, you've set up a cloud. Now you want to start applying some of these machine learning algorithms to your particular business problem. So one of the things that I see cloud ML developers do incorrectly because of the way they're taught in school is they think that they have to write the algorithm. Maybe at minimum, they'll use something out of scikit-learn. But what I'm going to bring to this talk, I hope, is my experience using some of the cloud services, because the cloud vendors are creating ML models that can just be used. Just give them some data. So you need to investigate what's there before you write something, because there might be something already there. So I call that Hello ML Cloud World. You have to try things out. So there are really three types of cloud machine learning. And notice I don't have write your own algorithm here because I don't find that that is usually what brings the most value on cloud ML. So the first one would be virtual machine with your model. The second one is Docker container with your or vendor model. And the third one is actually, in some ways, in my opinion, the first choice for when you're exploring. It's a vendor API. So another way to think about this is the first thing is called infrastructure as a service. You get the VM, but you have to do all the VM patching, you have to do all the libraries, you have to maintain the model. The second one is platform as a service. You might get a Docker container that already has a model on it. An example of this would be Amazon SageMaker that is scaled for you, and then you just supply the data. Or you could create a cluster of containers using something like Kubernetes and put your model on it. The vendor APIs are really interesting. These are literally endpoints that you give data to. And the data can either be labeled in case of images, like let's say you're looking for animals. These images have cats in them, these images have dogs in them. And then you supply it with a new image, and then the algorithm predicts whether the likelihood of it's a cat or a dog. It's an oversimplified example, but these vendor APIs are a real area to watch. Now, this landscape is where the cloud vendors are going to make profit because they charge for this. This is a premium service. And so they are creating a lot of solutions here. And what I have done is I created two charts, and this was actually for customers, because if you go to the Amazon console, you see that you have 150 services, and it's really hard to figure out what does what. Same for Google and so on and so forth. So I took just the machine learning services and I put them into a diagram. It does have a lot on it though, so let me show you what that looks like. And the idea here is you're going to figure out if you're going to build versus buy. And again, you can get these slides so if you want to dig into this a little bit more. But the blue level is the API level. So you can see, for example, for Amazon, they have something called recognition, which automatically generates labels for images. They have something called translate for languages that translates one language to another. Transcribe, which will take speech and transcribe it into text, so on and so forth. The middle layer is containers. And in the Amazon ecosystem, they have managed containers, which is shown on the right in purple. That's SageMaker. That is clusters of containers that have machine learning algorithms such as regression, classification already on them. The bottom level is infrastructure as a service. Now, even at that level, you can use pre-made virtual machines that have TensorFlow and GPU drivers. Now, interestingly, Google has the same in some ways. They have the same kind of offering. I want to call out to you this AutoML. The AutoML is a really interesting set of services. The idea is that you can supply, and we'll take for vision here, photos. But rather than just getting the labels out from Google's models, you can supply your own labels. So for example, I built with a student, or a student built it and I supported him, an evaluation of real estate, like how, if he bought apartments, how rentable those apartments would be. And he provided labeled images. So, highly rentable, medium rentable, not rentable, based on, the carpet, the walls, the whatever. And we created this model in a weekend, because once you supply this endpoint with labeled images, you don't have to create VMs or Docker containers or clusters or whatever. You just basically pay for usage for training hours. So this is really the new world of cloud. So it's really important when you're looking at your solution and your business requirements that you go through these grids. Okay, so you need to learn the Cloud ML services. Again, kind of redundant at this point. I made a course because I tend to use Google a lot, Google Cloud Platform Machine Learning, where and a repo where I actually give you sample code and Jupyter notebooks and scripts so you can try this stuff out with the sample data. So I encourage you to do that on whatever cloud you might use. Okay, so once you pick something, and one of the classic ones, if you're using a class of algorithms called neural networks, is MNIST. And this is evaluate using a neural network, what is the probability of a handwritten digit, and 0 through 9. So you pass in the data and labels, and then the algorithm will evaluate this. So I use this as an example of a hello world because I've been doing work with neural networks. And so I will, and you'll see this out there, I will try MNIST out. How long does MNIST take? It's actually kind of amusing that people got bored with numbers. And so there's a fashion MNIST, and it has black and white photos of clothing, shoes, that kind of stuff. So if you get tired of numbers, you can do fashion MNIST. But the point is, you can use this as a benchmark on a cloud. Like if you're evaluating Azure versus Google, for example, you can see how long did MNIST take on my particular solution. Did it work as I expected? What was the quality of the model? How long did it take to run given the input? What was the cost in training hours? Can it be reused? And then a really important point is, what is the bias? What did I expect? In the case of 0 through 9, how many zeros, how many nines? Does the data evenly distributed? And it never is in the real world. This is in the example it is here. And what is the bias in the algorithm? Because if you're using a vendor algorithm, there's bias because they've trained with their best effort at reducing the bias in the training data, but it's still there. So your data matters. So here's a little exercise. This is an actual document when I was in Australia. And if you just take a minute and look at it and think about, what do you see in terms of data? What is the data here? Now, most of you are probably programmers. And so you probably see, okay, we've got some types, basically. We've got the type is a tax invoice, and the tax invoice has attributes, the licensee, the licensor. And the second type is that it is a location or a place, Hub Australia, that's a co-working space. But just to show you, again, it's kind of like with my triangles, and something as simple as this, how there can be so much bias. I have a background as a database administrator. So when I look at this, what I see is this. The first thing is there's a missing border. So I wonder if there's cutoff information. I see blanks and defaults in the licensee address. There's a period, if you look really closely, in address. In the payment method, there's an or, which as a database person scares me because I'm like, what gets put in the database? The address is an Australian address, as a world traveler, and I don't know if you've traveled outside your country, you might have experienced this. I get so frustrated by airline websites that are formatted for the address of that country, because a lot of times as an American, for example, when I'm in Europe, I can't use European airline websites because they don't take American zip codes, for example. The time zone is a particularly interesting one. When I made a trip to Australia, I had my hotels booked by a group in France. And because it was a different day, when I arrived into each city, the first day I didn't have a hotel room for an entire month because they booked the wrong day because it's a different day in Australia. So time zone really, really matters. Anyway, the point is, bias is extremely important to understand in data because it's going to reflect the result of your model. And to talk about something very timely, this was on Twitter last week. So pulse oximetry, a key instrument of clinical management in COVID-19, can be inaccurate with darker skin. This is what we mean by racism built into healthcare, literally built into the equipment we use every day. And the reason for this is that there's bias in the training data. This is a very, unfortunately, known thing that we as a community need to learn how to put more effort into reducing, because, you know, as they're saying here, this is actually life-threatening, because this is one of the ways that they test when you have COVID-19, whether you need to be hospitalized or not. So extremely important. Okay, so model quality matters. So why do you have to use the cloud? Data volume. In my case, genomics, you have to. So you need to figure out how long will it take, what will it cost, and what to do first. So this is an example actually from Australia. This is a machine learning algorithm that one query was taking 500 hours on premise. 500 hours for one query. And the team came to me and said, let's put this on the cloud. What should we do? So the first thing is we tried to make sample data for that algorithm for variantspark and to try out some different cloud patterns. So we needed to create a small data set that was properly distributed. We needed to make sure it worked, it was verifiable. We could start looking at time and cost benchmarks. We wanted to have reuse, and we wanted to look at if there were any bias. And we made a fun example. The underlying data is human health, but we made fake or synthetic data around a fake disease being a hipster. And so we created the hipster index, which also had the nice effect of it grew our team, because people were kind of compelled by this. We did some talks about it, and they were able to understand it as well. So we were looking for 4 attributes that were genomically linked that were hipster. So this is all, you know, kind of humorous, but it helped us to validate, because you'd think, okay, well, why didn't you just go to scaling it on the cloud? You have to first learn those basics. So we use this to try out Google, to try out Amazon, to set up an account, to try something that comes back in 5 minutes. One of the challenges in machine learning is that, especially genomics, the hello world in a lot of my clients before my team worked with them would take like 8 hours. So they have to wait 8 hours every time before they would get a result. And so this is an important pattern. So talking about fairness, now I know not everybody's going to use TensorFlow, but TensorFlow has so many great tools for fairness. I really encourage you to check them out. So if you go over to the TensorFlow site, you can see they've got a section called Responsible AI, and they are cutting edge in terms of fairness. So they first talk about the workflow, and then they talk about, for example, this pair explorables tool shows you in your sample data, and I'll just go down into it here, where is the bias? And their information is excellent. So this shows you, like for a trend line, where the bias is, and to understand how to test for bias. There's so much information here. So I really encourage you to explore this link and look at the tools. And they have this, it's not just that tool, there's many other tools. Okay, so now we're getting to scaling. We've checked our data, we've set up our cloud, we've set up our dev environment. Now we want to take advantage of the cloud. This is actually from where I live. This is from Minneapolis, Minnesota. That's where I call home. And that's the famous cherry and spoon. So if you ever come to visit Minneapolis, come and see the big cherry and spoon. So scaling in my world also is reproducibility. So just like we had our Hello ML, we need to, with our actual algorithms, our actual data, we need to make sure that it works, that it's verified, that we have a predictable time and cost, because otherwise we don't get our return for using the cloud. This is a common problem, by the way. People just throw things in the cloud and they don't start with that Hello ML. They just go right to this, and then it costs too much because they haven't got the proper practices. They've done a lot of times what I call lift and shift. They've just taken their VM, taken their on-prem and made it to a VM, and you're not going to get the efficiencies a lot of times. So, we had a Jupyter notebook that we used for our production, and we were able to check this, and we got a sample run of this going like 5 minutes, 15 minutes, 1 hour, 2 hours. We just kept scaling up so we could have predictability. Also, you want to have documentation starting with a one-page diagram. So we eventually built a data lake, and we got that 500-hour query down to 5 minutes. So we had success, basically. And this is a link to a Medium article where it's a 3-part series. I talk about this process that my team took with that team that made variantspark in Australia to go from 500 hours on-prem to building this data lake architecture on Amazon, ultimately. This is a cluster of containers. So part of this is, you may have heard of DevOps. Appropriate scaling on the cloud or appropriate pattern is ML DevOps. So you're going to start by not clicking on any console. You're not going to click to make buckets or whatever. You're going to use scripts. But more than that, you want to have tests and you want to have templates. And in Amazon, that's CloudFormation. Now, there's many other vendors. There's Terraform. There's there's Polami, I think, is another one. But the idea is the configuration is code. Now, ultimately, you want to get to full continuous integration, continuous deployment, or CI/CD. But that, requires a big team of people, basically. And that's what that looks like for the general pattern for Amazon. Lambda would be your machine learning environment. So, but the idea is that you have multiple accounts, you have some sort of service or tool, and then you implement your machine learning model at scale. And with variantspark, they did that. They actually went out to the AWS marketplace, and they made it very reproducible for their audience, which is worldwide bioinformatics, which is kind of an ultimate use case, because we started, fully on-prem, 500 hours, and we got all the way through their own using it reproducibly into the minutes, and then making this available for the worldwide research community on the cloud through a template. So it really shows the patterns in terms of cloud ML very well. And again, I have to make a course. So this course is fully free. This is not a Lynda course. This is completely on GitHub. It has screencasts. It has sample code. It's GCP for bioinformatics. And one of the things I want to call out here is that machine learning is only a part of this. And that's another pattern for cloud ML, that machine learning is part of a greater solution that includes proper cloud practices. And with that, I think I'm at time. So I encourage you in your journey implementing cloud practices for machine learning. And I hope that you find my talk and my resources useful. I'm Lynn Langit. Thanks for listening.